now? I know a couple of us already talked to me. Just 2 so far? Okay. All right, here is Unit 6. This is our last unit, okay? This will take us about 5 to 6 weeks, minimum 5. About 6 is really where we're heading. Okay, you have a blank spot right there in the circle. Can you please fill that in? And then we will continue with the parent function. So graphing exponential functions, you're definitely going to need this skill to finish our part 2 of our project. So in your oval shape, it says, remember, your parent function in exponential will be different every time based on your b function, based on your b value. And b is normally, we say it's the base value, okay? So normally it's the base value. So b is the base value. Your parent function will always look like this. Y equals b to the power of x. So your input is now, what is that? Is that an exponent or is that a base? B is the base, but your input is now the exponent, the power. You're right. That's called, okay, so your input is now the power. And all the transformations are still the same. So let's look at our very first parent function. Y equals 2 to the x. Guys, what's your base here? Base is 2. Base is 2. So we're going to have an input and some outputs. Pick nice numbers. You don't have to pick the same numbers as we do, but pick some nice number that you like. I normally like to have -2, -1, 0, 1, and 2. Okay. So here's where it's going to start. We're going to go to, what's your exponent? -2, because we put x as -2. And we just learned a bunch of exponential rules. What do we do when we have an exponent that's a negative? We have to make it what? Move it, okay? So write it as a positive. How do we make all negative exponent positive? Put it over. So here we go. 1 to the power, 1 over, I meant 2 to the second, which is what? 4th. So this is 1 over 4. Okay, that's 1/4. Same thing with the next one. 2 to the -1. To make it into a positive exponent, we write 1 over 2. So 2 to the -1 is a half. 2 to the -2 is a 4th. And then the next one is very similar. 2 to the 0 is always what? 1. 2 to the 1 is always 2. And 2 to the second is always 4. So these are your values. Okay, let's plot those. -2, we're going to go up a very small amount, just a quarter. -1, we go a little bit more. Okay. And my pen is really, the tip is really big, so I'm not going to be able to distinguish a quarter and a half, but that's okay. 0 is 1. 1 is 2. And 2 is 4. Okay. That'd be wonderful if you can turn that off for me. Then connect the dots. So question for you guys. Can I pick any x values that I want? Yeah. How about the y values? Would it come out anything you want it to come out? Can y value whatever? Can you ever get a y value of 0? How come? Yeah, even if we put in a -100, right? If I go 2 to the -100, is that a very big number or a very small number? Very, very small, close to 0. But will it ever be 0? No. So in mathematics, whenever we have something that says, oh, well, it can never ever be 0, guess what these things are called? Asymptote. What kind of asymptote is this one? Horizontal asymptote. And that's a horizontal asymptote at what equation? at 0, but we have to use x equals or y equals. So what is it? Y equals to 0. Okay, so that's why we see in the bottom it says horizontal asymptote, y equals to 0. Because it is a parent function, our h and k are both 0. Because we didn't move anywhere, do we have any x-intercept? None. What's the domain? All reals. Okay. Of course, you can write it negative infinity to infinity, the interval notation. Is it an increasing function or decreasing function? Increasing. So that's from negative infinity to infinity. How about the rate of change? Varies. Okay. In pre-calc next year, you'll learn a little bit more. Now, this is a new concept. Is it an exponential growth or is it a decay? What does that mean is, it's a growth function class if your your base value is bigger than guess what? 1, okay? So an exponential growth, if your base, it's greater than 1, okay? Now, it's a decay if your base is in between 0 and 1, non-inclusive. So like a half, a quarter, 3/4, those are in between 0 and 1. So look at our base. It's our base greater than 1. So is this growth or decay? Growth. So since I circle these things, you can circle your answer. I'm just going to highlight them since I already circle them for the definition. Okay. X-intercept is none. How about y-intercept? Do we have any? Where at? 0, 1. What's the range? Greater than 0. So you can write y greater than 0, and some of it like it interval notation. I will accept either one. Because everything was increasing, decreasing is none. Is this function 1 to 1? Yes. Do we have any vertical asymptote? No. Okay. So that's the parent. By the way, is the parent function always 2 to the x? No, it's going to change every time. So you have to look at what's given to us. Okay. So let's go back to transformation refresher. If the a value is negative, what kind of transformation is that? Reflect over the x-axis. Reflect over x-axis. Now, if a is less than 1, an absolute value of a is less than 1, like a half, like 3/4, what kind of transformation is that? Vertical compression factor of whatever that is. Okay. If an absolute value is greater than 1, like 2, 3, 4, 5, it's a vertical stretch factor of that. Factor of a, whatever a I give you in the front of the base. H is either to the right or left. Okay, right or bless you. How do we know what goes right? Positive h. Left is negative h. K is either up or down. And same thing, positive k goes up, negative k goes down. Okay. So these are just the guidelines, okay? Step to graph any function in HK form. So step number 1. Alden, can you help me read number 1, please? Perfect, thank you. Number 2, Nicole?
Make a table of values for the parent function.
Perfect. Number 3, Griffin?
Identify a, h, and k.
Perfect. Number 4, can you help me read this one? Haley?
What's the transformation from the parent function?
Thank you. Number 5, can you help me read this one, Jennifer?
Make a new table of values using a transformation parentheses x, arrow x plus h, and y arrow. And then just say ay plus x.
Yeah, ay, that means we take the a value, multiply to y, and then add the k or subtract the k depending, okay? Caitlin, number 6, please. Perfect. Let's go to example 2. Okay, we want to identify the base right away, okay? What's your base value? Half. Base is 1/2. If I identify the base right away, I should be able to identify growth or decay. It is dk, okay, because it's in between 0 and 1. Then we are going to plug in some values. -2, -1, 0, 1, and 2. This is the part where your mind's going to have to love fractions. 1/2 raised to the power of a -2. So, just like anything else, how would we make this into a positive exponent? Okay, so I'm going to write this down. Eventually, you can go straight there. Would you agree that's an accurate way of making it a positive exponent? Well, what is really 1/2 to the second power? That's really, I'm going to write it up here because I'm out of space. Would you agree that's really 1 divided by 1/4? Oops, there you go. But that's really what? 1 times 4/1, which is really 4. You're right. So when you have a fraction and it is raised to a negative power, technically you can flip first and just make it into a what? Yep. So you can do this. So isn't it the same thing as to go, okay, what if I flip it 2/1 and then to the positive power of 2? Is that going to give you the same value? Yep. Okay. And that is always, always true. Okay. So when you have a negative exponent and it is a fraction base, you can flip your base and change the power into a what? A positive right away. Okay, so now when x is -1, -1 to the power of -2. I'm sorry, 1/2. What am I saying? 1/2 raised to the power of -1. Can I flip it right away? Okay, if I flipped it, what would I get? 2/1 raised to a positive power of 1 right away, right? So that will come out to be a 2. Okay, so that's a 2, and the first one's a 4. Then 1/2 to any power 0 is always 1. Then when x is 1, 1/2 to a power of 1 is, it's a half. Then 1/2 to the power of a 2 is 1/4. Okay, let's plot those. So -2, I will now go up to 4. Bless you. -1, we are now going to a positive 2. At 0, we're going to go to 1. At 1, we're going to go to a half. And then at 2 is a quarter. Can you see that this is decreasing? That's why this is called a decay. Do you think we have an asymptote? What kind? Yep. Okay, so go in and make these dash or dotted lines. So I'm going to write y equals to 0. That's a horizontal asymptote. H and k is going to be 0, 0 because we didn't translate anywhere. X-intercept, do we have any? Nope. Domain, what's your domain? All reals. Is it a decreasing interval or increasing interval? Decreasing, so from -infinity all the way to infinity, and I'm going to write NA on increasing. Can we write the rate of change? Varies. Okay. Y-intercept, where would that be? The range is? Y is greater than 0. Is it a 1-to-1? Yes. Okay. So both of these are parent functions. Both of them are parent functions. What's the difference between the two of them? One's a fraction, which results to a decay function, and one was a base of 2, which was a growth. Okay. All right. Any questions so far before? Oh, vertical asymptote. I forgot to fill that in. We should write what? NA. All right, here we go. This is no longer apparent. Example 3, f of x equals 3 to the power of, oh my, x minus 4 minus 1. Let's identify the base. What's your base? Yep, okay, your base is going to be 3. That means you have a parent function of y equals to what? base, which is 3, to always the power of x, okay? Always the power of x. So always the base should power of x for the parents. Let's fill out the a, h, and k as well. Do we have any a value? No. Remember, let me move this up, and then I'll move it back down. Guys, the a value, if you look at your original here, it's always being multiplied to the what? Oops, why am I? Yep, the base. Okay. So if you have an a value at all, it is always multiplied to the base. In this case, I don't have anything except a 1. Okay, so a value is 1. That means I don't have any vertical or horizontal, any vertical stretch or vertical compression. H value is what? It's x minus 4, so it should be positive or negative? Positive 4. Then you have a minus 1 at the end. That gives me a k value of what? Negative 1, just like that. And we are going to use x and y for inputs, negative 2, negative 1, 0, 1, and 2. So 3 to the negative 2. 3 to the negative 2. What do you think the output is? 1/9. Very good. Okay. So remember, I can flip it, right? And then raise it to positive power. That's how some of you got it so quickly. It's 1/9. Then 3 to the negative 1. 1/3. 3 to the 0. 1. 3 to the 1. 3. 3 square. 9. That's the parent for base 3. We have not seen these outputs. So the first one was base 2. The next one's base 1/2. Now, what do we do with a value of 1, h value of 4, and k value of negative 1? What do we do with those? Do we do anything with a value of 1? Nope. How about the h value of 4? Add it to x. K value of negative 1. Subtracted from 1. Okay. Go ahead and take a minute to give me new inputs and outputs for our f of x. Once you have your new, yes?
I just had a question.
Sure, go ahead, Anders.
Would you subtract the 1 at the start or the finish afterwards from the y?
From the y. So this would be 1/9, take away 1. So that will be negative 8/9.
So it doesn't become a new number because of the x transformation?
No, then the x transformation gets these. This would be negative 2 plus 4. That will be a positive 2 for the new input.
Okay.
Yeah. So only the x's get transformed with the x's, and the outputs get transformed outputs.
Okay.
So once you have all new inputs and outputs, can you compare with each other? Because if those are wrong, then you're going to have some wrong answers and graphs on this. This is homework 4 coming around. Tomorrow is CAS day, so I am only going to see you for 30 minutes. Who are the sophomores? Because I know most of us are juniors and seniors, so I'm expecting a lot of us to take it. Good. So sophomore, you just again, right? Tonight's homework is a review, so look at the parent function. All right, guys, here we go. New inputs. Well, give me the 5 new inputs. Throw it at me. 2, 3, 4, 5. Beautiful. Throw me the outputs. Negative 8/9, good. Negative what? 2/3, 0. 2, and 8. Guys, be mindful. You used to have a vertical, I'm sorry, not a vertical, a horizontal asymptote at where? 0. Your k value is now at -1. So where do you think your horizontal asymptote is going to be now?
-1.
Yep, I'm going to go and graph that right away. So I know my dots can never, ever be. Yep. Okay. Just like that. All right, let me pop my dots. 2 and -8/9. That means it's pretty darn close to the asymptote. Just can't touch it. 3 and -2/3. Pretty darn close right there. I'm going to make those two dots a little kind of about the same height, but can't help it. 4 and then now 0. 5 is 2 and 6 is now 8. All right. Remember, this goes left forever, just cannot touch the asymptote. Okay. Did you guys fill out the h and the k? What are those? 4, -1. X-intercept at 4, 0. Y-intercept, ooh, I gotta solve those, right? Y-intercept is when x is 0. Would you guys agree?
Yeah.
All right, let me work that out. Y-int, x equals 0. So y equals 3 to the -4th power minus 1. 3 to the -4th power is really technically 1/3 to the +4th power. True or false? True or false? True. 3 to the 4th is what? Because I know 1 to the 4th is 1, but what's 3 to the 4th? 81 minus 1. I need to find a common denominator, which is 81 over 81. So 1 take away 81 is -80 all over 81. That's it. Well, it's not bad, right? So y-intercept x is 0, so fill in 0, comma, -80 over 81. What's your domain? All reals. What's your range? Y is greater than -1. Increasing or decreasing? Increasing, because look, your base value is greater than 1. So increasing from -infinity to +infinity. That means decreasing is none. Rate of change, we are going to say it is going to varies. Is it a 1-to-1? For sure. Any horizontal asymptote? Where? Y equals to -1. Vertical is none. Growth or decay, and how do you know? Growth, because B is 3, which is bigger than 1. So growth, I'm going to circle growth. It said list the transformations right there. So can you tell me the 2 transformations that we have? Right 4, and then down 1. Beautiful. I'm going to wait for you guys to finish copying, because if I'm going too fast. Let's identify the base right away. What's our base? 3rd. That means I can actually go to the growth in k and say that it is decay. But we're going to wait to see if it's true or not, okay? What's your a value? -2. What's your h value? -1. What's your k value? -6, okay? So our parent function is y equals 1/3 in parentheses to a power of what? X, you're right. Okay, that makes it looks like a 1/3. And then we're going to have inputs and outputs. -2, -1, 0, 1, and 2. So 1/3 to the -2 power, which technically I can flip that quantity and write 3 to what power? 2nd, which is, output is 9. Okay. So we have now 1/3 to the -1 power, which again, I can flip the quantity, which is 3 to the 1 power, which is 3. 1/3 to any 0 power is what? 1. Okay, 1/3 to the 1 power, 1/3. 1/3 to the 2nd power is 1/9. Good. Okay. All right, tell me about the a value. What do you want to do with the a value? Multiply with y. The h value, subtract it from x. And then the k value of -6, -6. Yep. Why don't you take a minute or two to fill out our new inputs and outputs? Aaron, can you give me the new inputs, all 5 of them, hon? Thank you. So first output, okay? Jennifer, what's your first output?
-24.
Ooh, okay. Second output, Mark? -12. Third output, Katrina? Third output? -8, you said? Okay, thank you. Paige, fourth output? -6 and 2/3. Someone confirm so far? Okay. And last, Arlene?
-6 and 2/9.
2/9. Thank you. All right. I don't have enough grids for 824, but I will then start at -2, -12. Okay. -2, -12. 1 and 2. I'm just going to add 2 more tick marks. -1 and -8. 0, 6, and -6 and 2/3. 2, 4, 6. Should I draw my horizontal asymptote line so I know what not to go over? Yep, 2, 4, 6. So 6 is right there. So it's a -6. Okay. So I know not to go over that. So I have 0 and -6 and 2/3. And 1 and -6 and 2/9. I'm getting closer to the asymptote, just I can't touch it. There you go. Is it still an increasing function, y'all? Yeah, so is it still growth? Yes or no? Yes, okay, still growth. All right, h and k, we have -1, -6. Those are our h and k values. Am I going to have any x-intercept? Nope. Okay. Y-intercept at 0, comma what? Yep. Domain is always all rails. Range. Ooh, this one's interesting. Y is less than -6. Increasing interval from where to where? -infinity to +infinity. Decreasing, that means it's none. Rate of change will varies because it's not a line right now. Is it a 1-to-1? Horizontal asymptote is y equal to? That's right. That means vertical asymptote is none. This is where we are going to stop right now, so I will let you start on your homework. So the negative is reflection over the x-axis. Thank you. Then we have a 2, so it's a vertical stretch factor of 2. Then we have a -1 for h, so that's going to go left by. Then also the -6 for k, so down 6. Okay. So all of those right there.